Hi, I'm an old guy and I do maths, and we have a bit of a puzzle in front of us. The point 6 over 5 and 23 over 5, so that's an x-coordinate and that's a y-coordinate, is where two perpendicular lines meet. Okay, so perpendicular lines look like that. There's a right angle between these two lines, that is at 90 degrees to that, and I might as well say this, if the gradient of this is m, the gradient of this is negative 1 over m. So there's a relationship between the gradients, and it looks like that's going to be important here because we're talking about two perpendicular lines. The point at which they meet is 6 over 5 and 23 over 5, this point here, and I'm going to translate this into normal decimal numbers for you. That is not that, it is 4.6 and 1.2. There we are. So those and those are the numbers. I'll actually use fractions when I work this out. One line hits the x-axis at 15 and the other has a positive gradient. So we have a line with a positive gradient, that is bottom left to top right. We don't know where it crosses the x-axis or the y-axis, and we're not concerned with that. We have this point, 1.2, 4.6, so that's about there. And we're told that the other line is perpendicular, so it is there, it is that. The other thing we're told is that this point of intersection here is 15. Now, why am I so certain of that? Because if this has a positive gradient and it passes through those points, it can't look anything but like this. It could have a shallower slope, it could have a steeper slope, but it can't flick around and look like this. So this is one of our lines, and this is the other. And we have these points of intersection. Now, the other thing we're going to need is we're going to need a gradient. And I think we can get that. So we have 2 points, which are 6 on 5 and 23 on 5. And the other point is 15, 0, this point here. So we can get the gradient of this equation. If we can get the gradient of this equation, we can get the gradient of this equation. We know the points they pass through. Okay. So let's find this gradient. So this is x1, y1, x2, y2. And so 0 minus 23 over 5 is our top line. Our bottom line is 15 minus 6 on 5. Now, it is actually easier to refer to these numbers here, these decimals. So 0 minus 4.6 is going to be negative 4.6. And 15 minus 1.2 is going to be 13.8. Oh, I really don't think these things through, do I? Okay, so let's get out the calculator and find this gradient. So negative 4.6 divided by 13.8, negative 4.6 divided by 13.8. What does that come to? Well, that's interesting. It comes to negative 0.3 recurring, which is really nice because that's negative 1 over 3. That's wonderful. That really simplifies things. So we know that m2, we'll call the gradient of this m2, and we'll call the gradient of this m1. m2 is equal to negative 1/3. m1 is equal to 3, therefore. The relationship between these is that where you have perpendicular lines, if we take the easy example here, the line that's perpendicular to this will be negative 1 over this number, so negative 1 over 3. Okay, well, that's really good news. That's really simplified things. So, what do we know about these equations? Well, we have one equation, which is y equals 3x, we'll take this one first, plus c. And we know that it passes through 6, 5, and 23 on 5. 6 on 5 and 23 on 5. So 23 on 5 is equal to 3 times 6 on 5 plus c. Now, 3 times 6 on 5 is equal to 18 on 5. And we have 23 on 5 over here. And so that plus that equals that. That minus that equals that. So 23 minus 18 all on 5. Surprise, surprise. It equals, that's a surprise. It equals 5 on 5, which equals 1. So the equation of this line here, I hope you can see that line there, is going to be y equals the gradient, 3x plus c, 1. We found our first equation. Now, I'm going to need another piece of paper, so just bear with me while I get that and set that up. The other equation is y equals negative 1/3 x plus c. This is our other equation. And why is it so? It is so because our other gradient is that. We're still using the same numbers, 6 over 5 and 23 on 5. So let's go to work. 23 on 5 is equal to negative 1 over 3 times 6 on 5 plus c. So 23 on 5 is equal to negative 1 times 6 is negative 6. 3 5s are 15. That is negative 6 over 15, which is negative 2 on 5. Don't forget the plus c. Now, how did I get from there to there? Well, you can think of it this way. It's 1/3 of that. Now, 1/3 of 6 is 2. It's negative, so it's negative 2. Or you can do the multiplication. 1 times 6, 3 times 5. Common factor is 3. 3 2s are 6, 5 3s are 15. We get that. So, what do we know? We know that 23 on 5 plus 2 on 5 is equal to c. Well, that's great. Why is it great? Because it gives us c. That is 25 on 5. 23 and 2 is 25 on 5, which equals 5. So we have our second equation, y equals negative 1/3 x plus 5. That is our second equation, and that is how we got it. Now, I hope that all of the working wasn't too distracting. The key things here are to know that the gradients, because the lines are perpendicular, are the negative inverses of each other. So if one gradient is 3, the other gradient is negative 1 over 3. And that we can use the same point, because it is the point of intersection, we can use the same point to find the equations of each. And all I have been doing is substituting these values into the equation once I knew the gradient. It eliminates all but one of the variables, this, and with that in mind we can simply go about slowly chopping away at it until we find what the variable is, and in this case it's 5. Y equals negative 1/3 x plus 5, and over here y equals 3x plus 1. I hope you found that interesting and useful. If you did, please like and subscribe, and I'll see you next time. Bye.